Alright, so let's talk about the discovery of the nucleus by the Gold-4 experiment carried out by Ernest Rutherford. So in the previous videos, we've established that atoms are composed of subatomic particles, protons, neutrons, and electrons. We've also been able to see from the cathode ray experiment by J.J. Thomson that atoms are truly composed of negatively charged particles called electrons. So now in this video, let's see how scientists were able to discover the nucleus. So the nucleus of an atom is primarily composed of protons and neutrons. So this wasn't known in the early days until the discovery made by Ernest Rutherford in the Gold-4 experiment. So when we talk about atoms nowadays, we usually use this structure, right? And in this structure, we have the nucleus in the middle that has the proton and the nucleus. And then there are electrons around the outside of the atom. But of course, we didn't always know that the atom looked like this in the early days. Okay, so before the Gold-4 experiment, scientists, particularly J.J. Thomson, thought of the atom as a uniform, positively charged sphere with electrons scattered within it. So this is the Plum Pudding Model. So we have positively charged pudding. So all these were considered to be a positively charged, and these were considered to be the electrons. So this Plum Pudding Model is like a sliced orange. You know, when you slice an orange into an equal half. So we have orange like this. So it's considered that all of these are soft. So these were considered the positively charged pudding according to the Plum Pudding Model. So in this sliced orange, we also have the seed scattered around it. So these were like the electrons in the Plum Pudding Model. So Rutherford's experiment using the alpha particles directed at the thin gold foil challenged this Plum Pudding Model. So this is a structure from the Gold-4 experiment. So in the Rutherford's Gold-4 experiment, alpha particles, which are known to be positively charged, so they were fired at the thin gold foil, and most of these particles passed straight through this gold foil, indicating that the atom might probably be composed of an empty space. So when we try to look at the Gold-4 experiment thoroughly, so in the Gold-4 experiment, alpha particles were shot through a thin gold foil. So, and most of the alpha particles pass through this gold foil straight. So, this almost brought the conclusion that atoms are composed of empty space. But then they noticed that some of these alpha particles were also reflected. Some are reflected and some were deflected as well. So this indicates probably a hard dense substance is inside of the atom, because for you to shoot alpha particles through a thin gold foil, and from the Plum Pudding Model, it was considered to be, atom was considered to be an empty space that has just electrons within it. So but you shooting the alpha particles, most of the alpha particles pass through the gold foil, but some of them were deflected and some of them were reflected. So this tells that there is a hard dense substance inside of the atom, and because this some of these alpha particles were being deflected and were being reflected, it was thought to be a positively charged substance. So remember that things that have the same charge repel each other. So they reasoned and come to the conclusion that there is something small and hard inside of the atom. He also concluded that this hard substance inside of the atom must be positively charged since it repels the alpha particle, and it was therefore called the nucleus. So, and Rutherford concluded that the nucleus isn't just a hard piece of positive charge, but it is composed of many protons. So the conclusion from Rutherford was that the nucleus is not just composed of one positively charged proton, but that it's composed of many protons. So we have this to be like it's composed of many protons.